All right, so let's talk about the first lesson of Unit 2. This is section 2.5. So we covered 2.5, the properties, last unit briefly. So we've talked about the addition property, the subtraction, multiplication, division property, reflexive, symmetric, transitive, and substitution properties. So we just talked about all of those. And now we're going to use those to write proofs. So some of these proofs are a little weird and it's something different that you've never done before, so just be open-minded about it. So this is how you do a proof. You start with a T-chart and you're going to have two columns on this T-chart, and the first column is going to be statements and the second column is going to be your reasons. Okay, so here's the problem. What is the value of x? Justify each step. So when you're doing these geometric proofs, you have to break it down to the simplest step-by-step instruction. You can't just go straight forward into the math problem. You have to explain why. It's a lovely part about proofs. So the first thing is, well, how would you solve this problem? Well, instantly you would start thinking 2x plus 30 plus x, add those two together, and they're all going to equal 180, right? You would set up an equation. But on a proof, you have to even dumb it down even less than that and say why. Well, why do we know they equal 180? Well, we know that angle AOM and angle MOC are a linear pair. Linear pair. And that is what our given statement is. We can see that just by looking at a picture. That was one of the things in section 1.4, I believe, that you can just assume by looking at a picture. Okay, step 2. What does that mean for them to be a linear pair? Well, I just told you that means they add together to be 180. So that means angle AOM plus angle MOC equals 180. So how do I know that? Well, that's just the definition of a linear pair. All right, we're almost to the math part. Now step 3, and you do need to label each one of your steps on both sides. So step 3 is, now we're ready to set up our equation. So we're going to plug in 2x plus 30 in for the AOM, and then x in for the MOC. So let's do that. That would be 2x plus 30 plus x equals 180. What did I do? I just plugged that in. What's the mathematical term for plugging something in? That is the substitution property of equality. All right, the next step, if you're going to solve this mathematically, how would you do that? Well, you would combine like terms. You would start by combining 2x plus x. So this is our fourth step. 2x plus x would give you 3x plus 30 equals 180. And the reason behind that one would be, just like I said, combine like terms. That's a step, that's a reason in its own. We're getting really close to being done. So then, if you were going to solve that equation, what would you do? Well, you would minus 30 to both sides, right? So that would be 3x equals 150. So what did I just do? I minus 30. So that would be a subtraction property of equality. All right, and the very last step, how would you solve? Divide by 3. So step 6, when you divide that by 3, would be x equals 50. Oops, I did the wrong color. So x equals 50. And how did I know that? Or what property was that? We just did the division property because we divided. So I know this is weird and strange, but the more you do it, I promise the better you're going to get. Some things I just want to note before I move on. Whenever you can see, like right here where I'm subtracting to both sides, that is not a step. Like the green part is what I'm talking about. So a lot of people want to make that its own step, and it's not. It goes with that step, in this case number 4. Or like here where we're dividing both sides by 3, don't try to put a line right here all the way across and make that its step, because that goes with the step in 5, if that makes sense. Okay, let's do another one. Here's another geometry problem. So what is the value of x? Justify each step. And they tell you, given ray AB bisects RAN. So let's just talk this out before we even start setting up this proof. How would we solve this? What is a bisector? Well, that puts splits that big angle RAN into 2 equal pieces, right? So we know these right here are equal. So eventually we're going to set those equal to each other and try to solve it. So I really just walked you through the layman's terms of the proof, but now we get to write it out. So you have your statements and your reasons. Let's start with number 1. So the basic part, you're always going to start with given. So what did they give you? They said that ray AB bisects angle RAN. Okay, so what does that mean to bisect something? Well, that means it splits it into 2 congruent angles. So that means angle RAB is congruent to angle BAN. And how do I know that? Because that's the definition of an angle bisector. Okay. Well, we need to start doing some math to solve for x, so we need to get rid of that congruent symbol and get an equal sign in there, because you don't solve math problems with a congruent symbol. So the third step is we have to switch that symbol to an equal sign, because if angle RAB is congruent to angle BAN, then angle RAB is equal to BAN. I know this is weird. So how do I know that they're equal? Because that's the definition of congruent angles. I know that seems like a redundant step, but that's just how you do this. Okay, number 4. Let's see, now it looks like we have it all set up. Now we're just ready to plug those numbers in. So RAB we said was x. And angle BAN, they tell us, is 2x minus 75. So what did I just do there? I plugged it in, or I used the substitution property of equality. Now we get to do math. So how would you solve this? Well, you would get all your x's on one side, so let's subtract 2x from both sides. That would give you negative x equals negative 75. So what did I just do there? I used the subtraction property of equality. That's our last step. How would you solve? How would you get the x? Looks like it's by itself, but that darn negative is in the way. So we have to get rid of that by dividing both sides by -1. So we just did the division property of equality. And so that would give me x equals 75. And so I know this was a lot of work to figure out what x equals 75, but I'm not concerned that you know what the answer is. It's this process is to know that you know how to explain it. That's what a proof is all about. Not that have the right answer, but you can actually explain why. Okay, the next page, these are some of those same properties, the reflexive, symmetric, and transitive, but those are properties of congruence instead of equality. Okay, so now let's write a proof for this one right here. Let's set it up before I start explaining it. Statements and reasons. So 1 is always going to be our given, so they tell us the measure of angle 1 is equal to the measure of angle 3, and why? Because it's given. So we know that, and we're trying to prove this. So this is what our last line should look like on the left. So let's talk about this. So if I have this, so we're trying to prove that this angle and this angle are congruent, which they are. It's not a yes or no question. They're telling you right off the bat they are congruent, so you don't have to question it. So how you do this? Well, let's talk about it. So if this angle and this angle are the same, if 1 and 3 are the same, and they share angle 2, so 1 and 2 is what makes up AEC, and 2 and 3 equals BED, then they have to be the same because 1 and 3 are the same and they both have 2 added to them. Okay, so I know it's weird, I know, stick with me. So let's write it out. We are going to have, and this one is a little strange, so step 2, I'm going to tell you, we need to say the measure of angle AEC equals, well, AEC is this one right here, so that's going to equal the measure of angle 1 plus the measure of angle 2. You see that? It's just AEC is angle 1 plus angle 2. That's it. So what is the reasoning? How do I know that one angle plus another angle equals the total angle? Well, that's called the angle addition postulate. So the angle addition postulate. Okay, the next one, let's do this one in blue. So the next one is BED angle. Actually, I'm going to say it backwards like they do right here. So the measure of angle DEB, well, that's made up of 2 different angles. That's the measure of angle 2 plus the measure of angle 3. And what is my reasoning? Well, that's the same thing. The angle addition postulate, and I am abbreviating, and that's okay if you want to too, or if you like to write out the words, feel free. Okay, so we've got that stuff down. Now, how can we tie this together? So this is, we've said, let me get my pointer here. So we've said that AEC equals 1 plus 2, and DEB is 2 plus 3, and then they said 1 equals 3. So I'm going to, now the next step is, the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. How did I get there? You might want to take a second to look at it. Whenever you're looking at it, look from this step to this step. So as you can see, we have measure of angle 1 here and the measure of angle 1 here, measure of angle 3 there, and the measure of angle 3 there. So what did I do from the first step to, if we're going from 1 to 4? Well, I added the measure of angle 2 to both sides, which you can do that, right? You could add, as long as you add to both sides of the equation, you could add anything you want. So that would be the addition property of equality, because you can add something to both sides of the equation all day long. Okay, now let's go. We have from here, measure of angle 1 plus the measure of angle 2. Well, that looks like this right here. So what does that equal? Well, that equals AEC, so I can plug that in right here. The measure of angle AEC is going to equal the other one, angle 2 plus angle 3. That's right there. So it'll be the measure of angle DEB. So what did I do? When I plugged that in, I used substitution. So substitution. Property of equality. So we are finished because we ended up where they did. We have a measure of angle AEC equals the measure of angle DEB. So we are finished and we did it. I'm going to skip the last one because I don't want to make this video too long, but it's very similar. So it's AB is congruent to CD, just like angle 1 and angle 3 were congruent. And then we're supposed to prove that from A to C is congruent to angle B to D. So you set this up almost the exact way as you did the other one. It's just, instead of angles, you have segments. So, alrighty, thank you for watching.